Assalamu alaikum. Today we will start our new topic in organic reactions, which is some alcohol reactions. I want from you, as I told you in the last video, to recall some informations about alcohols, like naming, structure, and all these things. Okay. Now I want from you just to revise some things like general formula of alcohol. General formula of alcohol can be CnH2n plus 2 and O. So it's alkane formula with one more oxygen atom. There is no any double bonds. Alkane formula, that means the compound is saturated, or it can be CnH2n plus 1 and OH. We remove H from here and it's appear as hydroxyl group. Okay, now classifying of alcohols. The first alcohol is primary alcohol. Primary alcohol, whereas OH bonded to carbon, again bonded to two hydrogens and bonded directly to one carbon. It can have a chain of carbons again here. It's primary alcohol. Then we have secondary alcohol. Secondary alcohol, the hydroxyl group bonded to carbon, which is bonded only to one hydrogen, and the two other bonds will carbon with carbon. What about tertiary alcohol? Hydroxyl group bonded to carbon, which is not bonded to any hydrogen. Okay, not bonded directly to any hydrogen. This is the three types of alcohol. Now, what about reactions of alcohol? First, conversion of alcohol to halogenoalkane, which is our previous compounds. Okay, I want to tell you, alkene alcohols and halogenoalkane, very important chemicals in organic synthesis. Okay, it will take us to different functional groups. Now, this reaction called halogenation. In this reaction, used to replace hydroxyl group by halogen, we need different conditions for each halogen. So this reaction condition depends on the halogen. There is no constant reaction or constant conditions for the reaction. It depends on the halogen. If we talk about chloride, bromide, or iodide, okay, if with each one we have different conditions. Let's start with chlorine. Okay, chlorine, alcohol react with phosphorus pentachloride. Alcohol react with phosphorus pentachloride to give me chloroalkane, hydrochloric acid, and another inorganic product. This reaction very vigorous reaction in room temperature, so heating not required. Okay, in this reaction heating not required because it's a very vigorous reaction. Okay, usually used with secondary and primary alcohols. Okay, again we will not study the mechanism now and why it occurs like this. Okay, for tertiary alcohols, HCl used, not BCl5, not phosphorus pentachloride. We will use hydrochloric acid. Okay, and this tertiary alcohol with hydrochloric acid, it will give us chloroalkane with water, and again occurs at room temperature. Now, if we talk about bromine reaction, what will happen with bromine? This reaction occurs at two steps. The first step is to prepare hydrogen bromide. Okay, how we can prepare hydrogen bromide? Mix potassium bromide with 50% concentration sulfuric acid. Okay, to can give hydrogen bromide. If the concentration of sulfuric acid is greater than 50%, what will happen? The product will change. Okay, sulfuric acid will act as stronger oxidizing agent, very strong oxidizing agent, and will give me bromine. So it should be 50%. Okay, products depend on amount of KBr used, another factor. Now, KBr with sulfuric acid, it will give me hydrogen, potassium hydrogen sulfate, hydrogen bromide, or if I use more potassium bromide, I will get potassium sulfate and hydrogen bromide. Okay, so the this product, potassium hydrogen sulfate or potassium sulfate, depends on the amount of potassium bromide used. Okay, concentration of sulfuric acid, again I mentioned this point, it should be exactly 50%, cannot be more, because if it is more it will oxidize bromide to give bromine and the reaction will completely change. So the first step, it's preparation of hydrogen bromide. Okay, in our level it's not required to discuss why we need hydrogen, or in our syllabus, sorry, it's not required to discuss why hydrogen bromide should be fresh prepared in this reaction. Okay, then when hydrogen bromide form, it will react with alcohol to make a displacement reaction here. Okay, and prepare halogenoalkane or bromoalkane and water. All three reactants should mix together at the same time. We say step 1 and step 2, okay, just to explain the reaction, how it will occur, but I don't want from you to understand, this reaction occurs at a beaker, then we mix the reactant with alcohol. No, we mix the three reactants at the same time, sulfuric acid, potassium bromide, and alcohol. But this reaction occurs first. The product then attack the alcohol to give me the final product in this reaction. Here we talk about the bromide, then we will talk about iodine. In iodine, reaction occurs at 2 steps. Okay, in the first step, we are mixing phosphorus with iodine, to get phosphorus triiodide. Okay, then phosphorus triiodide will attack the alcohol. Here I want from you to note the ratio, because we have 3 iodide here, so each one of phosphorus triiodide react with 3 molecules of alcohol. This reaction need reflux to occurs, okay, and give me the product with acid in the product side with the organic product. Then our next reaction in alcohol, it's dehydration of alcohol, and we'll study this topic in next video. Keep all the notes which related to unit 3 in these topics. It is unit 2 topics, but it's highly connected to unit 3 questions about the experiment conditions and all these things. Okay, see you. Assalamu alaikum.